lights here in one sec. Okay, so today we're going to look at part 2 of this unit. And specifically, the specific thing we'll be looking in this unit is square roots. But in order for me to teach you square roots, there's something else I need to show you first. It used to be part of the grade 8 curriculum, but I'm not sure how strongly they cover it. It depends kind of teacher to teacher. So some of you might be seeing some of the content in here for the first time. Okay, so let's take a look at what the actual grade 9 math curriculum says about this. It says, you need to determine the square root of both a positive rational number that are perfect squares, determine whether or not a rational number is a square number and explain the reasoning, determine the square root of a positive rational number that is a perfect square, identify the error made when you calculate a square root, determine the positive rational number given the square root of that positive rational number, and explain with examples why a positive rational number has both a positive and a negative square root. Now again, for some of you, some of these words on here you'll be seeing for the first time. Others of you may have at least seen some of these wordings before. So let's start with a couple quick questions out there to sort of test the waters. What do you think a square number is? What do you think a square root is? And what do you think a perfect square is? Does anyone have any ideas? Yeah. So like you're talking about graphically, right? Yeah. So if we were to draw a perfect square, what would it look like? What would a perfect square look like if you were going to draw it? Any idea?
Four sides, all identical.
All identical what?
Straight.
Lengths, right? The length of the sides would be equal, yes. Like 15 times 15? You're definitely on the right ballpark, yeah.
A perfect square is when the number can be divided into an even number.
Divided into an even number. Again, in the right ballpark, yeah. I like a lot of the ideas you guys. So it sounds like some of your grade 8 teachers did a good job. They kind of at least introduced this idea. So does anyone think they know what a square root is? What do you think? So it's kind of the opposite, right? Definitely on the right track again. You know what, guys? There's a big room way over there where you guys can sit and talk and be like shake your drinks and stuff. It's called the cafeteria. You can sit in there and you can also not learn your math in that room, but it's less rude if you go and sit in that room. So just a thought if you want to do that. But in other words, if you guys could be quiet, that would be great. So yeah, the square root is kind of the reverse, right? Sort of like when you multiply numbers and then you divide them, you're kind of going one way or the other, so you're definitely on the right track. So, perfect square, what does that sound like? Someone said about it graphically that it would be perfectly square, right? Yeah.
So a perfect square is like, yeah, it's even on every side.
Even on every side, yeah. Okay, so who's feeling strong? Anyone feeling strong in here? Like, who's the tough guy in here who thinks they got some strength in their hands? So I want to try a little activity with somebody. I'm going to grab a piece of paper right here. Whoops. Oh, I'm falling all over the place. So all you got to do is fold it in half. Who's feeling mighty? Fold it in half. Okay? Okay, come on up, one of you guys. Come on up. Okay, fold it in half. Yeah. Simple enough activity. Too easy. Just fold it in half. Simple enough. How many pieces of paper do you have now? How many layers of paper? 2. Fold it in half again. How many layers does he have now? 4. Now, before he continues, that's 2 folds, right? He's folded it twice. How many do you think he can do? You think he can do 10 folds? Who said 10? Boy, these guys have a lot of confidence in your strength. They got some serious confidence in you. So you've done 2. Okay, fold it again. So this is your 3rd fold, right? Fold number 3. How many layers does he have right now? So let's think of the sequence here. He went from 2, 4, 8. How many are going to be on the next fold? Ah. Okay, so this will be fold number 4, right? How you doing? You feeling it yet? A little bit. Yeah, he's feeling it a little.
That's 5, right?
No, that's 4, right? That's 4 folds.
I folded it twice.
As many as you can.
That's 5, and then you're halfway.
5. He's halfway there. Can he get to 10?
Absolutely. I have full confidence. 2. I've never been more sure what
I think 7's the maximum you can get.
So this is 5, right?
No, that was 6. He was just at 5.
Are you sure that's 4? Is that 6? Okay. So now going for 7. Oh, he's getting the foot in there. No. He's using the edge of the table. That might help. He's using my name plaque. Don't wreck my name. He's trying. He's getting there. That's 7, right? All right, now we're going for 8. Or are we going to give up at this point?
Oh, don't give up. I believe you on that.
8.
Teamwork. We can do teamwork. Great.
Well, you could take over if you want.
Here, give it to me.
We'll do it together.
Wait.
Just come on, guys. We don't have all day here.
I just want to feel how, like, holy frick. That's awesome. Yo, here's holding around a pencil.
You realize that some of us are right now being entertained by not the might. That's 8?
Yeah, that's 8.
Can you do 9?
We can do 10.
Can you do 10? All right, while these guys are working on it, I'm going to ask everyone to sit down, and these guys can keep working on it. We're going to, because it's not so much that I'm trying to prove how mighty these guys are, but the reality is there's kind of a pattern to this, as you can guess. Okay? It's okay. It's okay. Shh. You guys are getting way too excited about this, okay? The reality is the number of folds and the number of layers had a pattern-like relationship to them, okay? The number of folds was increasing, which is why it was harder, right? Think about how much actual paper they're trying to fold at 8 folds. How many sheets are they trying to fold? Anyone have an idea? Like when it was the second fold, when they're going to the third, they're folding 4 pieces of paper in half. When they're going to fold it for the 4 times, how many pieces of paper were they trying to fold? 8, right? Etc. This relates directly to what I'm about to show you in something called exponents and powers. And by the way, we will also be revisiting this. As if you recall in the course outline, there is a unit called powers and exponents. I just sort of reversed the order. So I'm going to introduce it to you now, and we're going to revisit it in that unit as well. Okay, the reality is mathematicians are extremely lazy people. And they like shorthand ways of writing things. So, for example, here, the number 81 represents the number 3 multiplied by 3 4 times, right? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So it's, in a standard way to write it out, this is the way you've been taught, that would be a nice piece of math to write out. But mathematicians are lazy. And they thought to themselves, you know what? I don't want to write this like this. This is too much work. And so in order to accommodate that, a new system was developed that I'm teaching to you now called powers that use exponents. Okay? So in order to do this, the way it works is you have 2 components to this. One component's called the base, and the other's called the exponent. And here's how it looks. What I'm representing here is 3. That's the number I'm multiplying. That's my base. Okay? Whoops. So my base is 3. The number of times I'm multiplying it is 4. I'm multiplying it 4 times. That's my exponent. The whole thing is called a power. So what I have here is I have 3 to the power of 4 is a way you can express that. But we kind of, again, have to think of each component there. This is the base. This is the exponent. It is a shorthand way of writing the same thing as I have here. Yes?
Wouldn't there be like 3 times 3 times 3 times 3 times 3 if it was 4 exponents?
well, that's what this means, right? What this means right here is it's 3 multiplied by itself 4 times. Here's the most common mistake. When people see this, the most common thing they think is, this means 3 times 4. That's not what it means. Okay, otherwise we would have written it that way. What this actually means, again, is 3 multiplied by itself 4 times. So this is, again, what's called a power. Okay? A power that uses the 4 as an exponent. Those are fancy words, but it's just a simple thing, very much like folding the sheet of paper. We're multiplying it by itself each time. That's what was happening when he folded the paper. He was taking the number of sheets and multiplying it by itself as he folded it. Okay. There are other ways to read this. Okay? 3 squared is the common way. Some of you have probably seen this maybe even in science class. They'll say something like meters squared. Okay? So 3 squared means 3 to the power of 2, which is essentially 3 times itself, 3 times 3. Okay? 2 to the power of 3 means 2 times 2 times 2. Some would refer to that as 2 cubed. And this is maybe a way you can visualize it. Now, some students get confused by the diagrams. Don't be, okay? Sometimes it's easier to look at the diagram, sometimes it's not. So if the diagram is confusing, blank it out, okay? It doesn't help you understand it, that's fine. Okay? So why do mathematicians do this? It's easier, okay? It's more efficient. It's shorthand, so it's lazier, which makes it a little more efficient. They're a shortcut way of writing the same thing that you could write just by writing different multiplications. And as you will see, especially as we get the course a little more advanced, especially if you're going to take a little more advanced math next year, these powers and exponents can easily start being used to create more complicated mathematical formulas, especially in algebra. Okay? For now, let's just start by looking at it in its simple form. Okay? And the easiest way to calculate these is your calculator has a button designed to work with exponents. Okay, now again, it depends on the calculator, which is why I'm going to recommend as well, you make sure you bring your calculator to work on this. Now, for a lot of you, this might even be your phone. If you have a smartphone, if you have some sort of fairly advanced phone, it might have a calculator feature that'll work fine for this. It should be able to work this out. Okay? Now, the only problem with using your phone is you will not be allowed to use your phone for your math final exam. Okay? So you can use it for assignments in class, that's okay, but if you get too used to your phone and then right before the exam you switch to a new calculator, which is kind of annoying, so I would recommend you get a calculator, okay, in addition to your phone so that you can get used to your calculator. Now I'm just going to turn the light on for a sec. This is just one calculator I grabbed out of my drawer. The calculator you're going to need for this course is a scientific calculator, which means it has more than just like add, subtract, multiply, and divide. There's a few other buttons on there. You won't need them all, but one of the ones you'll need is a way to use exponents, a way to calculate these. Okay? On most calculators, it'll be a button like that one. Okay? That's saying something to the power of something. That's what the button is on this one. It's got a YX button on there. But you may have to look on your calculator. It may look a little bit different. It won't be one that has an X and a 2. That only works to square something. Okay? This one is a little more versatile. With this one, I could calculate what 2 to the power of 8 is. And you know what? If you don't have a calculator with that button on there, you could still do this without the calculator. Or sorry, without that button. You would just have to do a lot more work. You'd have to go 2 times 2 times 2, keep going 8 times to get the answer. But with a button like this, it's a little bit easier. You just type 2, y to the x 8, which means 2 to the power of 8, and you'd get the number 256. Okay, so let's do a quick calculator activity. Those of you who have a calculator, and if you don't, I've got one here who wants to try this one. Anyone? Anyone? Let's punch these in. Let's see if you guys can get an answer to these. What's 3 to the power of 7? What's 4 to the power of 8? And what's 0.3 to the power of 3? So again, you're going to have to sort of play this. And if you're unsure on how to use your calculator, now's not a great time, but come up and see me, and we'll work with it together. It's possible that it's a slightly different button. I'll help you to kind of figure out your calculator, okay? Okay, do you guys have numbers for these three? Anyone got numbers for all three of these yet? I'm going to put the answer up just to see how you guys did. Okay? All right, so for the first one, 3 to the power of 7, anyone get an answer? What's the answer? 189? You did that in your head. You're the human calculator. Who else has got an answer for the first one, 3 to the power of 7? What have you guys got? Just say it out loud. 2,187? Okay. What did people get for 4 to the power of 8?
Is it actually like a 2,000 number?
65. Well, here's the answers. Okay. 2,187 is correct. 65,536 is correct. And then the last one is 0.027. So this is a bit of a calculator activity. But you can see here how these big numbers to work with, that the use of powers and exponents helps you to crunch these really big
I
numbers.
did it the wrong way. I did it like 3 times, not 7 times. I did it the wrong way.
So, sorry, how did you do it then?
Like, well, I did 3 times 7.
Yeah, which is wrong.
Oh, wait, yeah, that's right.
It's not 3 times 7. Remember I said that's the most common mistake. The most common mistake is students doing that is going 3 times 7. No, it's 3 times 3, 7 times. Yeah, 7 times. Which is why this would be hard. I was like, I don't know if you're going to be able to do that in your head. You could, but it would be a lot of calculating to get that going in your head. Okay? Okay. As well, it gets tricky. It gets tricky with signs. So here's an example of 2 different powers that would have a different outcome. 3 to the power of 4 is being used in both cases. The negative sign is in both cases, but the brackets might affect things. Okay? Now, let's just focus on the second one for a second. How would you interpret that? What does that look like to you? It means the number -3, yes?
See it as the 3 is negative, but the exponents are positive.
Okay, but let's just focus on this one. Okay, forget this one. What's being raised to the power of 4? What's being multiplied by itself 4 times? -3. Okay, so think about that. Let's start with just the first multiplication. What's -3 times -3? +9, correct. Why? Because it's a negative times a negative, right? So let's think this out. I forgot to start my smart notebook here. Okay. Now, what we're then going to do is multiply it by itself again. But I don't want you to think about all this mental math at this point. I just want you to think about what's actually happening with the signs here. Because we have -3 times itself 4 times. Just one second, I just want to load this. My apologies, I didn't have this ready to go. Okay. Come on, smart notebook. You can go faster than that. Is it ever? Oh, here we go. Okay, it's just on my second screen. Okay, so here's what we had. We had -3 to the power of 4. Now, I don't want you to even think about the 3. Just think it's negative something. I'll draw a happy face. Negative happy face times negative happy face. What would it be? A positive, let's just say happy face again, or sad face. Doesn't matter. Right? We know 3 times 3 is 9. But think about what we're doing here again. We're taking a negative times a negative, but we're doing this 4 times. Times a negative, times a negative. A negative times a negative times a negative times a negative. So think about what's going to happen here. What's a negative times a negative? What's a positive times a negative? And then what's a negative times a negative? So the final answer will be positive, right? So the way you do this on your calculator might also affect the sign a little bit. What if this was -3 times the power of 3? Let's think about what it is. That really means -3 times -3 times -3. Whoops. So what's -3 times -3? It's 9. Negative times a negative. Then we'd have +9 times -3. The answer would be 27, but what would the sign be? Negative. Right, negative. Whereas if it was to the power of 4, our answer was positive. Okay, we'll finish up tomorrow, everybody. We'll finish this up tomorrow. Have a good day. If someone could pin the door open, please, on their way out.